welcome to the first video in my series on how to make a simple brain-computer interface system. Alright, so the first thing that we're gonna do is you want to download OpenBCI GUI. So what this is just like, it's an easy way to visualize all your data, control all your data, know what's going on with your BCI, especially when you're starting out. It's a good way to get an intuitive grasp of how everything works. And so this is the program. So first thing you want to do is like open up your browser and just go to openbci.com. Go to their downloads page. And then just download the GUI version for whatever operating system you're running. So for this computer, it's Mac OS. So just to give that a download. Alright, so while that's downloading, you might want to set up your actual board. So the way this works is that you've got all these pins here, so pin 1 to pin 8, those are all your channels. So these are what you're going to get your EEG data from. You got bias and ground here. I don't really know the differences between ground and bias, although I have read on the forums that bias is kind of like a better version of ground. So that's where you put your grounding electrode in, and SRB over here is where you put your reference electrode in. Now, if you're using the OpenBCI Ultra Cortex, you've probably got like these little ear clips or something like that that you clip on your ears, and your ear clip will essentially go on SRB and bias. If you got anything else like an OpenBCI cap, so that's ground, reference and bias are these two. So reference and ground. And then if you're alternatively, you could if you don't have the ear clips, you could get like cup electrodes or sticky electrodes and just stick them onto your ears as well. And it will look the same. And you just use ground and reference. Yeah, all good. You'd want to so for this example here, this one is going to be our reference electrode, which we plug into here, and this black one's going to be our ground electrode, which we plug into bias, and then the rest of it. The OpenBCI GUI kind of has like a color-coded channel system, which usually corresponds to the wires that you have over here, but you can use any color for any channel. It doesn't really matter. It's just helpful when you're using the GUI. So just plug all your wires in. Cool. Alright, once you have all the electrodes plugged in and you got your battery supply all set up, what you want to do is you want to take your USB dongle and put it in your computer, USB slot. Mine's all the way out here, so my computer's down that way, but I got a power port thing going on where I can just plug it in over here. Alright, and that will connect to my computer. And then you want to just switch this on. Alright, cool, and you're good to go. Alright, make sure that you put that in first, then turn this on, then open the GUI, alright? So that first, then that, then open the GUI. It's really finicky. If you do it in the wrong order, sometimes it doesn't work. Alright, so once you got the GUI open and all your headsets set up, you'll be met with this. Wait for it to load up. Okay, now to connect to your headset, you go to live from Sidon, serial from dongle, unless you're using a Wi-Fi shield. You might have one. I don't at the moment, so I'm just going to connect through Bluetooth. And then you go to, so this is where you work out where your connection's coming from if you're using Bluetooth. I think mine's this one, so I'm just going to give it a scan. Yep, that's all good. And now you just click start session and it will open up a little thing for you to visualize your BCI data. Okay, so yep, click start stream and here we go. So this is the data coming in. I'll explain what everything means in a second. Okay, so first thing you're going to want to make sure is you have a notch filter set for 60 hertz. I mean, sorry, 50 hertz. By default, over here it's set to 60 hertz. Change it to 50. Now the difference is most ambient electronics in anywhere but America oscillate at a frequency of 50 hertz, so you want to cancel them out. America has to be different because they like to, annoy the rest of the world with whatever they're doing. Okay, and then you have a bandpass filter of 5 to 50 hertz. Now this can be adjusted depending on what kind of analysis or EEG activity you're looking for. 5 to 50 hertz is just like a very general open window. Okay, now I'll explain a little bit about what each of these things are showing us. I'll change this to band power. Okay, so over here, this is our raw data that's coming through. So each one of these rows represents a different channel on the headset. And a good way to tell if it's working is to, well, first of all, you want, when nothing's happening, for these lines to be nice and clean, very flat. Like the flatter it is while nothing's happening, the better the signal you got. Although you don't want it to be completely flat because that means something's wrong. Maybe there's like not a good connection, one of your electrodes is not working and something's railed. So yeah, with that, so this looks like a pretty decent signal connection considering that we're using dry electrodes. So a few things that we can do to make sure everything's actually working is, one, you should be able to see blinks. So I'm going to do a few blinks now. Blink. And you can see them there. Those are blinks. Blink, 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 blink. Yep. All right, another thing you can do to make sure everything's working is a jaw clench. So if you clench your jaw really hard, you're going to see it. All right. So yep, I just keep clenching my jaw. It keeps coming up because it's picking up muscle activity rather than brain activity. And one more thing you can do to make sure everything's working is, strangely, when you close your eyes, your brain is more predisposed to oscillating at an alpha frequency. So when you keep your eyes closed, you should be able to see a massive spike in around about this area here. So I'm going to try that out now. All right, there we go. Once I opened my eyes, I saw it drop a little, but I saw it rising around about the 12 hertz frequency. Okay. So yeah, it's working. And so yeah, what this window over here is it's this, but it's being passed through a fast Fourier transform. So what it's doing is it's taking the raw data time series data and then transforming it into the frequency domain. So it's sort of like comparing its similarity to a certain sine wave, with the sine wave having like an oscillation frequency of whatever these values are here. So like for example, it like over here at 12 hertz, it would be comparing its the oscillation of this to like a 12 hertz sine wave. And these can tell us different things about like what the brain's doing at the time. So for example, for a very general example, your brain might be producing beta waves when you're like in a normal waking state, although when you're more focused or something like that, it might produce more alpha waves, which are those 12 hertz things that you saw rising before. And this is kind of what's going on here. Right. And that's actually what we're going to use to build our first BCI system. So we're going to try to make something that picks up whether or not you're focused by judging the differentiation between your alpha waves and your beta waves. Now, luckily, OpenBCI has something built in for that. So I'm just going to change the layout to allow us to have more windows open here. I'm going to do a 2x2 and open up over here the focus widget. All right, so this is going to judge, it's going to look at our alpha waves and our beta waves. And so if you have low beta waves and high alpha waves, it kind of assumes that you're focused, right? So I'm going to try to distract myself now, make myself like not focused. I'll like fiddle around with my phone or something, play with this thing. All right, and now I'm going to look back at the screen and try to focus myself. There we go. See, all right. So that works. Oh, in the zone. All right, and then I'm back to fiddling around and stuff. Cool. All right. So what we want to do is, one thing you might notice is once you actually get focused, it's easier to stay in that state, strangely enough, and that's something that comes up in neurofeedback. Okay, what we're going to make is a system that detects if you're focused, and if you are focused, it's going to turn on a light. All right, that's what we're going to make now. So, okay, I guess that's for the next episode. So this first episode was just like learning how to set everything up. Yeah, next episode I'll show you how to turn a light on with your thoughts.